Hello and welcome to Geometry. Today we're taking a look at section 5.3. We've got number 16 pulled up here. What we're looking for are the measures of the unknown angles here, 1 and 2. There are a lot of ways to do this because we know PQRS is a parallelogram. Parallel lines. There's a lot to do. It's a parallelogram. We've got some parallel lines here. We've got a lot of congruencies. We're going to need to label some things here if we want to talk intelligently. So we'll call this point A, call this point B, call this point C. Now we can take a look at QPC, and that's 60 degrees. But it's congruent to QAB. So that's got to be 60 degrees too. These two guys are congruent. And we've got 100 degrees here, PSR, which is the same as PQR. So what we have now is a triangle. Call it AQB. We've got 100 here. We've got 60 here. We're looking for this angle. It's going to be 20 degrees. 180 minus 60 minus 100. 20 degrees. Okay, what about angle 2? Well, this isn't a quadrilateral. A, B, R, C, P. It's not a quadrilateral. This parallel line and this guy aren't cut by the same transversal. We're going to have to get a little clever here because this does impact into the side. Okay. 100 degrees. We know that this angle up here is going to be 80 degrees. So this is going to be, Alright, let's take a look. This angle, PCR, or angle 2, it's exterior to triangle PCS, which implies that angle 2 is equal to the sum of angle CPS and angle PSC. If you have an exterior angle, it's equal to the sum of the two opposite angles. So we just need to know what CPS is. And I mentioned before that this guy is going to be 80 degrees. Yeah. Let's draw a little diagram here. Take a look at that. We're going to have, let's see here, parallel line, transversal, and this will be QRS, and that is P right here. We know that this is 100 degrees, and it's supplementary to this angle, so that's got to be 80 degrees, because they must sum to 180 degrees. Parallel lines, transversal, interior angles on the same side of that transversal, they sum to 180. So this angle right here is is 80 degrees. And the angles in a parallelogram are opposite to each other. Angle QRS is congruent to angle QPS. So it's 80 degrees. And the angle QPS is equal to the sum of angles, let's see here, QPC and CPS. So that's going to give us, let's see here, 80 degrees is equal to, we know QPC, 60 degrees. So that means that this guy has got to be 20 degrees. Okay. 20 degrees plus 100 degrees is equal to angle 2. Remember, that stuff in green is what we're looking for. Looking for that. 20 degrees. And then PSC we said was 100 degrees. So angle 2 is equal to 20 degrees plus 100 degrees, 120 degrees. All right, and that's it for that problem. Next, we're going to take a look at 5.3, number 28. This is an interesting problem. We're given a rhombus. We're told to find some angles, but all we're given are side lengths. We're told that BE measures 7, CD is 14. This is a rhombus. All its sides are congruent. That's the definition of a rhombus. So, if this is 14 degrees, then this is 14, this is 14, this is 14. Okay, so now we have this triangle, BEC. Wonderful triangles here. This measures 14, this measures 7. BE and EC are perpendicular. The diagonals of a rhombus are perpendicular to each other. That's theorem 5.23. So, oops, get rid of that. That's a right angle. This is a right triangle. Okay, so what? Length of a side, twice the length of a side. This is a special triangle. We go all the way back to section 3.3 and we take a look at it and, oh, wait, no. That doesn't work. It's side and then the hypotenuse would be S, the triangle that I'm thinking of, 30, 60, 90. So this would be 30 degrees. This would be 60 degrees and this will be 90. This would be S. And then this long side would be S divided by 2. That's not what we have here. We need to think about something else for this. We need to think about something else. And we need to look at a really important property of rhombuses. It's not just that the diagonals are perpendicular to each other, but we can actually go ahead and show that the diagonals are perpendicular bisectors of each other. That's pretty awesome right there. We know that the angles bisect each other. That's theorem 5.25. So we could show that triangle BEC is congruent to triangle DEC, etc. But this is congruent to that, is congruent to that, is congruent to that. So what we know is, let's redraw this guy. Let's redraw this rhombus very shakily. This is 14, this is 14, this is 14, this is 14, this is 7, this is 7, this is 7, this is 7. Wait a minute. This whole side is 14. So if we go back up here and we look at triangle B to D to C, BDC, it's equilateral. So this measures 60 degrees. This measures 60 degrees. The angles bisect each other. This guy right here, 30 degrees. It's an equilateral triangle. All right. Next question is 5.337. We're given a quadrilateral. A, B, C, D. We need to show that it's a parallelogram. All we know is that A is congruent to C, B is congruent to D. So we need to show that these guys are parallel and these guys are parallel. But we don't know that right now. That's what we're going to go ahead and try and prove. Okay, and to do that, we need to know some theorems, essentially. We need to take a look at our parallel line theorems and come up with a game plan to show that AD is parallel to BC. Once we do that, we can just flip the argument and we'll have AB parallel to DC, no problem. Let's see here. These guys are congruent. I wonder if we could show that BAD plus ABC is equal to 180 degrees. If we could, then that would give us some parallel lines. So our goal is, we'll just say angle B plus angle A is equal to 180 degrees. Now, this thing's a quadrilateral. It's got 360 degrees in it. It is equal to the sum of angle A plus angle B plus angle C plus angle D. But A is congruent to C. So I can cross that out and I could replace it with angle A. And D is congruent to B. So I could cross that out, replace it with angle B. So we would have A plus B plus A plus B is equal to 360 degrees. Let's combine some terms here. 2 times angle A plus 2 times angle B is 360 degrees. Now let's just divide by 2, and that'll give us 360 divided by 2, 180 degrees. 2 times angle A divided by 2, angle A. 2 times angle B divided by 2, angle B. Hey, those angles are supplementary. That means that AD is parallel to BC. Does that show that AB is parallel to DC? Almost. We'd need this angle plus this angle to be 180, but that's easy enough. Angle B is congruent to angle D, right? We were given that. So that means that 180 degrees via substitution is equal to A plus D. Which means that, let's see here, AB, right, AB is parallel to DC. So that means that ABCD is a parallelogram by the definition.